Here we have another example for graphing rational functions. This one is going to have that weird asymptote that's not going to be horizontal, so I wanted to make sure to put one of these on here. Vertical asymptote, take your denominator, set it equal to 0. So x equals 2. We can go ahead and draw that one in. EBA, leading term over leading term. Leading term on the top is x squared. Leading term on the bottom is x. The degree on the bottom is not bigger, so it's not an automatic y equals 0. This does reduce to just an x, so our EBA is y equals x, and that is the line that goes through the origin and has just a slope of up 1 over 1, so it's this perfectly diagonal line right here. X-intercept, set your numerator equal to 0. You know, we could do that whole thing, but in the end we're getting 0. So 0, 0 is that point. Now if you notice, when I plot 0, 0, it's right on that asymptote. So technically this is not a true asymptote. We use it more as a guideline to help us see what's happening with our graph, which is why we may have points on it, we might cross it. So some of those, it's definitely a gray area as far as asymptotes go. Y-intercept, plug in 0 for x. 0 squared over 0 minus 2. 0 over a negative 2. We're getting that same point of 0, 0, which is already plotted. Now to get our table of values, we're going to go 2 before and 2 after that vertical asymptote. So 0, 1, we skip 2, and we pick up with 3 and 4. Now when x is a 0, this is what we actually just did right there. I know that our y is going to be a 0. When x is a 1, I'll just go ahead and plug it in. 1 squared over 1 minus 2. This 1 over negative 1, which is a negative 1. Now when x is 3, we have 3 squared over 3 minus 2. So 9 over 1, or just 9. When x is 4, we have 4 squared over 4 minus 2. 16 over 2, which is 8. So we'll plot these points and see where we stand with our graph. 0, 0 is on there. 1, negative 1 is right there. 3, 9, which actually, let me erase these little marks so I can just say 3, 6, 7. It's going to be right around there. And then 4, 8. 1, 2, 3, 4, 5, 6, 7. Oh yeah, right there. So right now, I actually would say I'm not really sure what my graph is going to look like. You know I have this weird asymptote thing happening. So what I'm going to do is get a couple more points just to see what's happening, you know, maybe out here. Where's the point going to be out here at a negative 6? And maybe over here at a positive 6. What's happening with our graph? So on these, I definitely encourage you to plot more points because a lot of times we might not be sure what's happening yet. So negative 6 squared over a negative 6 minus 2. 36 over a negative 8. Now this can reduce. 4 goes into both of these, so what is this, 9 halves? A negative 9 halves, or negative 4 and a half. Right here. So I'm going to go ahead and plot that point. Negative 6, let me erase my squiggles. Negative 6, negative 1, 2, 3, 4 and a half. And then we plug in a positive 6, which will be 6 squared over 6 minus 2, so 36 over 4, which is just a 9. So when we're at a positive 6, if I erase some of this right there, positive 6, we're up back here at a 9. So, you know, we kind of get familiar with how these graphs look. So I know I'm going to connect these right here. There I am crossing that asymptote, but that's okay. That's going to go down. We won't cross the vertical ones. And the slanted one we'll just kind of use as a guide for the direction of our graph. So this up here is going to be heading like that. So again, the more points you plug in, the better of an idea you'll have of what your graph is doing.